Figure 4 shows a sketch of part of the curve C1 with equation y equals 2x cubed plus 10. This is a cubic and would actually at some point turn and come back down. And then part of the curve C2 with this quadratic equation. We're asked to verify that the curves intersect at x equals a half. So let's look at C1. When x equals a half, we can just sub in and find the y value. We don't need to set these equal to one another. We can just find the y values for both and show that they're equal. So 2 times 0.5 cubed plus 10 gives me 10.25. And then C2, I feel like I should show a little bit more working for this one. So I've got 21 minus, well, it's going to be 15 over 4 minus 7. And we're expecting that to also be 10.25. Which it is, great. So therefore, C1 and C2 intersect. X equals a half. Essentially, we've been given a root of when we set the equations equal, and we can use this to help us in part B, which is to use algebra and show all stages of working to find where they intersect again. And that is going to be, it's going to be one of these 2 points. Can't quite tell from the graph which one it is. I mean, we could complete the square and so on, but it doesn't matter too much. There would be another point down here, by the way, where they would intersect. So we're going to get a negative solution, and we're going to reject that one. Okay, so C1 and C2 intersect when 2x cubed plus 10 equals 42x minus 15x squared minus 7. So I can turn this into a cubic equal to 0. So 2x cubed plus 15x squared minus 42x plus 17 is equal to 0. But remember, we know that x equals a half is a solution. And that implies that 2x minus 1 is a factor of the cubic. So we can do well, there's different methods you can do, but I'm just going to do a polynomial division. So I'll get x squared when I do 2x cubed divided by 2x, multiply back through. Subtract gives me 16x squared. Bring the minus 42x down. 2x into that gives me plus 8x. Subtract gives me minus 34x. So minus 17. So we've got 2x minus 1 times x squared plus 8x minus 17 equal to 0. I'm not really bothered about 2x minus 1. We've already got that one, but I'll leave it there. So x equals a half, or x squared plus 8x minus 17 equals 0. We can see that that's not gonna factorize. You could put it straight in your calculator, although it does say to show all stages of working. So I think I'm not going to do that. I'm actually going to complete the square. Not too bad to do. X plus 4 squared gives me x squared plus 8x plus 16. So I'm going to minus the 16, minus the 17 as well. X plus 4 squared equals 33. x plus 4 equals, don't forget the plus or minus, root 33. So x equals minus 4 plus or minus root 33. Okay, and one of these is going to be negative, so I can ignore that one. So the other one is then minus 4 plus root 33, which in fact was the second one. So I've got a half here. I've got the negative one here, minus 4 minus root 33. But this is the one that I'm interested in, minus 4 plus root 33. So he has a positive value of x. So its x coordinate must be minus 4 plus root 33 or root 33 minus 4.